Assalamu alaikum. My name is Muhammad Wajid Zulfikar and my registration ID is 16T37. Today we are going to discuss the lecture 3 of the digital signal processing. In this lecture we are going to start the basic systems and basic signals. Systems and signals. First of all, we will look towards the systems in which we will discuss the causal and non-causal systems. Then we will look towards the linear and non-linear system. And then at final we will look toward the time variant and time invariant system. In the signals, we will look toward the two basic signals that are the step signal and the next signal is impulse signal. Now let's start our discussion with the causal and non-causal system. As we know that systems are very much great importance in our daily life. So causal systems are those systems which value depends on current and past value of the system. For example, we have the system y of n is equal to x of n. Let's suppose we put any value in this system. Let we put n is equal to 0, and then y of 0 is equal to x of 0. Then this is the x of 0 is the y of x of 0 is the present value, and y of 0 is also the present value. Let's we take another example of the system, that is x of n minus 1. In this system, let we suppose we put n is equal to 0, x of 0 minus 1, x of minus 1. This gives us the value of the minus 1. This means this is the past value. So we can explain causal system as the systems which depends on the future and which depends on the past and the present value of the system. For example, we combine this system as y of n is equal to x of n minus x of n minus 1. For example, let we suppose put the value of 0, then we get x of 0 here and minus x of 0 minus 1 minus 1. This is the present value and this is the past value. So we can explain that this system is the causal system. Let's discuss the second system, which is the non-causal system. Non-causal system. Non-causal systems are those systems in which our value depends on the future value of our system. Depends on future value. The non-causal system are those systems in which value depends on the future value. Our system depends on the future value which we put. For example, let's we take the example of the non-causal system as y of n is equal to x n plus 3. Then if we put n is equal to 0, then we get the value of x of 0 plus 3, x of 3 बन जाएगा हमारे. Then this system is the non-causal system. So we can explain this system is the non-causal system. For example, if we take an example of the system, let's suppose we have the system y of n is equal to 1 over 5 aka is equal to minus 2 for 2 x of n minus k. Let's first of all we open this mission as x of n minus 1 n n minus 2, so minus minus plus हो गया plus x of n plus 1 plus x of n minus 0 plus x of n minus 1 plus x of n minus 2. So we open this system as, no, if we put the, let's suppose we check here, if we put the value of n is equal to 0 here, this system is gives future value. If we put n is equal to 0 here, then x of 1, which is the future value. If we put n is equal to 0 here, 0 means 0, then this is the present value. This is the present value. If we put n is equal to 0 here, this is the past value. And if we put n is equal to 0 here, then this also gives us the past value. Here we have the two future values, and here in this value x of n minus 0, when we put n is equal to 0, then we have the present value. And in the next system plus x of n minus 1, if we put 0 here, then we get the past value. And if we put x of n minus 2, n is equal to 0, then this will also give us the past value. If any value of the system is in future, then we will say that this is the non-causal system. If any value is in the future, then we can say this is the non-causal system. If, for example, we have a value in past, present, and future, then we will say this is the non-causal system. If the values are in the present, only in the present and past, then we will say this is the causal system. Otherwise, we will say that this is the non-causal system. If any value is in the future domain, then this is the non-causal system. And the next system which we are going to discuss is the linear system. What is the linear system? We will look linear system. In linear system, we have to follow two conditions. First of all, the system should be homogeneous. First of all, system must be homogeneous, and second, it must follow the additive property. As we discussed, the linear system is that system which follow the homogeneous and additive property. These two properties are also called the principle of the superpositions. This is called the principle of superposition. First of all we discuss the homogeneous property. Homogeneous properties. First of all, if we have the system, we have the system x of n, and this is our system, and it gives us the value of y of n. Then the homogeneous property will be a x of n should be in the a y of n. This means that if we multiply any multiple or any constant or any values into the input, then it must have also to be in the output. This is called the homogeneous system. For example, we take the example of the homogeneous system as, let's 3 of, first of all we have the system x of 3 of x plus n. This is our system. We have to check whether it is the homogeneous system or not. Then we will look towards it will pass through the system, and we multiply it with alpha x of, for example, we can say this is the alpha, alpha of 3x plus n. Then if we pass it through the system, then the value should be 3x plus n into alpha. Let's check it. Alpha 3 of x plus alpha of n. It gives us the value at the output side. We take the alpha common as 3 of x plus n. Then we can say that this is the homogeneous system. It gives us the same value as we multiply the constant or any value to the input, and gives us the value at the output side. This is our homogeneous system. And in the additive property, we discuss about the main thing. Let's for example, we have two signal x1 of n plus x2 of n. Then after passing through the systems, we have to get the value y1 of n plus y2 of n. It means that if we have the system at the input side, and we should have also, if we add this system at the input side, then we must have also to get the values at the output side when we add these both the system. If for example, if we get the value of the scale, for example, we have the x of n scale. If we put the system in that, for example, if we have the x of n plus 1, this is x of n plus 1 ka scale. If we put the value of the scale in the system, then this system will change. It means that it will open the n plus 1 scale, means n square plus 2 n plus 1. This will not give us the same system. If we take these two systems as for example n square plus 2 n plus 1 plus n 1 square and 1 square, or n 2 square plus 2 n 2 plus 1, then it will gives what value? It will gives n1 square plus 2 n1 plus 2 n2 plus 2. But we did not have the value of our system in the 2. We just only have the values of n square plus 2 n plus 1. And same for the second system, though this system is not the linear system. The linear system will be the only system which follow the superposition principle. What is the superposition principle? Superposition principle is that principle which follow the homogeneous and the linear properties. This is for the linear system. Now, next system is our time variant and time invariant system. Time variant system are those systems which change with respect to time. And time invariant system are those systems which doesn't change. For example, if we have any system, then we put x n plus n. If we have any system, then we have to put the value of n plus n not, we can say n plus n and n plus s. Then we can put this value in the system and check whether our system is time variant system or our system is a time invariant system. Next the topic which we are going to discuss is the basic signals. First of all, we will look toward the impulse signal. Impulse signal is that signal which gives us the only value when at the point 0. That means we have n is equal to 0, it gives us 1 or 0 otherwise. What does this mean? If we have our system like as in the graphical representation, if we have a value 0, then this will give us the 1, otherwise this system will give us 0. This is our impulse signal. And in the unit step signal, what does it say? It gives us the value in the unit step signal. Unit step signal. Unit step signal is that signal which gives us the value of 1 for all the values of n which is greater than or equal to 0. And greater than or equal to 0, all the values will be 1 and otherwise 0. In the continuous time domain, we get the signal it as n of 1, gives us the value 1 and far greater than or equal to 0. And in the discrete time, we get the values as 1, 1, 1, and 1, and so on. This value is the 1. This is our unit impulse signal. If we take the derivative of the unit step signal, I said this is the unit step signal, not the unit impulse signal. Sorry for that. If we take the integration of the unit step signal, then we get the unit impulse signal. And so these two are the interrelated to each other. If we take the derivative of unit step signal, then it gives us the impulse signal. If we take derivative of unit step, then it gives us unit impulse signal. These two are the basic signals in our digital signal processing course. In the next lecture, we will also looking these signals further. Today, for now, this is the all of this lecture. I hope you will find this video a little bit entertaining for yourself. Thank you very much. Okay, Allah Hafiz.